Hello everyone. In this video, I'm going to discuss the concept of limits and how to evaluate limit functions. Alright? So limit, by definition, is the value which the function becomes closest to as x becomes closer and closer to a corresponding value. And it is denoted by this expression, the limit of f of x as x approaches a. And in evaluating limits, any of the following may be produced. So here is a summary, or here is a table of summary of the possible results when we are going to evaluate limit functions, right? So if the evaluation result of a limit is L, or any value or any expression, therefore the limit is L. So as an example, the limit of 2 plus 1 as x approaches 1, that's equal to 3. Because the limit of a function is basically the limit or the function of a, right? So if the evaluation result is 0 over L, therefore the limit is equal to 0. So for this one, the limit of x minus 1 over x as x approaches 1, if we're going to determine the function of a, and a here is 1, we have 1 minus 1 over 1, or that is 0 over 1, and that's equal to 0. For the third for the third type of evaluation result, we have L over 0, that if this is the case, the limit does not exist. Alright, so that is our conclusion. Or the function becomes discontinuous at x equals a. Alright, so if the limit is x plus 1 over x, and if we're going to determine f of 0, so that would now be 0 plus 1 over 0, that's equal to 1 over 0. Therefore, there is no limit as x approaches 0. Alright? And for the last evaluation result, we have 0 over 0. So if we're going to determine f of a for a given function of x, and the result is 0 over 0, the conclusion here would be indeterminate. Alright? So as an example, we have x squared minus 1 over x minus 1, and or the limit of x squared minus 1 over x minus 1 as x approaches 1. And if we're going to solve for f of a, right? So if this is f of x and a is 1, f of 1 is 1 squared minus 1 over 1 minus 1, and that is 0 over 0. So that means to say that the limit for this function is indeterminate. Right? But we're not going to stop there, because as a solution, we're going to transform the function f of x to produce any of the above forms. Alright? So if the result is indeterminate, what we are going to do is we're going to transform the given function in order for us to produce any of the above results. Alright? So we're going to manipulate, if that is a algebraic expression, then we're going, or if that is an algebraic function, we're going to algebraically manipulate the function. And if that is a trigonometric functions, we're going to use identities. Alright, in order for us to produce any of the above functions. So for as an example, if we're going to manipulate the function x squared minus 1, that we can still factor it out, because the factor of x squared minus 1 is x plus 1, x minus 1. Alright, and then this factor all over x minus 1, we have a common factor here that we can cancel out, because we can actually cancel out x minus 1 in the numerator and x minus 1 in the denominator, thus leaving us the limit of x plus 1 as x approaches 1. And if we're now going to determine f of 1 in here, because this is our resulting limit expression, so we now have 1 plus 1, and the limit of x squared minus 1 over x minus 1 as x approaches 1 is actually equal to 2. Alright? So this is the summary, this is the summary of the limit evaluation result and the conclusion for each result. Alright? Now let us discuss the theorems on limits. Okay. So for the theorems on limits, we actually have 8 theorems here. Theorem number 1 is the limit of a constant is equal to the constant itself. So if you have a limit of a constant, whatever the value of a here, the limit of a constant is the constant. So say for example, limit of 5 as x approaches negative 2 is still equal to 5. Alright? So for the second theorem here, the limit of a function of x as x approaches a is the function of a. Okay? So limit of f of x equals, or the limit of f of x as x approaches a is actually equal to f of a. So we're just going to replace a, or we're just going to replace x with the value a here. So as an example, the limit of x cubed as x approaches negative 2 is equal to negative 2 raised to 3, and that's equal to negative 8. Okay? The third theorem here, the limit of a constant multiplied by a function is constant multiplied by the limit of the function. Alright? So, as a general expression here, the limit of a constant multiplied by a function as x approaches a, we can bring out the constant here, alright? So we can write the constant before the limit word, and then we're just going to evaluate the limit of the function as x approaches a. So as an example here, the limit of 3x squared as x approaches 3, that's equal to 3, because we can bring out, or we can write, or we can write 3 before the limit function, and then we're just going to evaluate this limit now. So we have 3 limit of x squared as x approaches 3, so that's 3 multiplied by 3 squared, because this is now the function of a, right? So 3 squared is now the function of 3 for f of x equals x squared, and that is now equal to 27. Right? So that's theorem number 3. For theorem number 4, the limit of the sum of 2 or more function is equal to the sum of their limits. Okay, so this also goes with the difference of 2 or more functions, right? So say for example that we have a limit of x squared plus 3x plus 2 as x approaches 4, we can determine the limit of each term independently. Alright, so this one can be equated to the limit of x squared as x approaches 4 plus 3 limit of x, because 3 can be written before the limit function, so that's 3 limit of x as x approaches 4 plus limit of 2 as x approaches 4. So this one, function of 4, we have 4 squared, and then function of 4 with x, that is 3 times 4, and then the limit of a constant is equal to 2. So if we're going to evaluate this one, that's equal to 30. Right? So also, the limit of the product of 2 or more function is equal to the product of their limit. So if we have a limit of u of x multiplied by v of x as x approaches a, then we can say that this is now equal to the limit of u of x as x approaches a multiplied by the limit of v of x as x approaches a. Alright, so basically we can determine, or we can evaluate the limit of a product separately, okay, by determining the limit of one function and then determining the limit of the other function, and then we're going to multiply the result. Alright, so as an example here, we have the limit of x squared plus 2 multiplied by x squared minus 4 as x approaches 1. So this is equal to limit of x squared plus 2 as x approaches 1, and limit of x squared minus x raised to the 4th power minus 2 as x approaches 1. Alright, so if we're going to determine now the limit of this one, so that's 1 squared plus 2, and then the limit of this one as x approaches 1, that's 1 raised to the 4th power minus 2, and that's now equal to negative 3. Alright, and then for the 6th theorem, the limit of the quotient of two functions is equal to the quotient of their limits, provided the limit is of the denominator is not 0. Right? So there is a condition here. So the limit of a quotient of two functions is equal to the quotient of their limits, provided that the limit of the denominator is not equal to 0. Right? So if we're going to have an example here, the limit of sine squared theta over tangent cube theta as theta approaches pi over 4. Alright, so we're just going to evaluate the limits of the numerator and the denominator independently, and then we're going to evaluate the result. And the result of this problem would now be equal to 1/2. Okay? And for our last theorem here, right? So we correction of what I just said earlier. We have 8 theorems in this material, but actually we have 7 only. Right? So if alpha is measured in radian, therefore the limit of sine alpha over alpha as alpha approaches 0 is equal to 1. Okay, this is a property, or this is a theorem. All right. So if we have problems that will result to this form, or this general form, or this theorem, I should say, then we're going to apply trigonometric identities in here. All right. So those are now the different theorems of on limits. All right. So if we already know the different theorems on limits, then we can already solve exercises here. All right, so let's have our first example here. So given the limit of, or we are required to evaluate the given limit of a certain function. So for the first one, or for the first item, find the limit of 2t squared plus 1 all over t squared plus 3t minus 4 as x approaches 0. So in the first theorem, or if we're going to go back to our theorems on limit here, the first theorem here, actually it's the second theorem here. The limit of a function as x approaches a is actually equal to f of a. So what we are going to do here is that we're just going to determine, or we're just going to evaluate the f of a in this problem. So this would now be equal to 2 multiplied by 0 quantity squared plus 1 all over 0 squared plus 3 multiplied by 0 minus 4. And if we're going to simplify this one, that is now equal to 1 all over negative 4, or basically this is equal to negative 1 over 4. This is now the limit of this function as x approaches 0. Second item, find the limit of x squared minus 1 all over x squared plus 3x minus 4 as x approaches 1. So again, if we're going to determine f of 1 in this function, this would now be equal to 1 squared minus 1 all over 1 squared plus 3 times 1 minus 4. And if we're going to simplify that, that's equal to 0 all over 1 squared plus 3, that's equal to 4, minus 4, that's equal to 0 as well. Alright? So, if we're going to recall my discussion, or our discussion in the evaluation of limits, it falls under the fourth category, or fourth type. If the result is 0 over 0, that means to say that the limit is indeterminate. And we're not going to stop there, because there is a solution to this one. Alright, and the solution to this is that we're going to transform the function f of x to produce any of the above forms. So if the result is not L, or is not 0 over L, or is not L over 0, and the result is 0 over 0, we are going to manipulate the given function in order for us to produce any of these results. Alright, so since the evaluation of the given function is indeterminate, what we are going to do here is that we're going to transform this function. Alright, and if we're going to transform that one, basically we can factor out something in here, and then we can cancel out something there, so that we can produce any of the possible limits. Alright, so if we're going to manipulate this one, x squared minus 1 can be factored out. Alright, so that is the difference of two squares, and the factors of x squared minus 1 are x plus 1 and x minus 1. All over, the denominator is also factorable, And the factor of x squared plus 3x minus 4 is actually equal to x. Alright, so that's x plus 4, x minus 1. Okay, so you can factor this one by trial and error because the factors of 4 or negative 4 is 4 and 1, or you can have it as 2 and 2. However, I'm going to use 4 and 1 because the middle term is equal to 3. And since the sign is negative, 1 here is positive and 1 here is negative. Alright, so it can be here or vice versa. And since the middle term is positive, therefore, this must be the positive one. And this is the negative one. And then we have x and x here. Alright, so if we're going to use the FOIL method here, and if we're going to expand this one, we have x squared plus, or yes, we have x squared plus 4x minus x minus 4. And this is now equal to x squared plus 3x minus 4. Right? So this is now the factor of x squared plus 3x minus 4 as x approaches 1. Now, you will notice that we can cancel out x minus 1 in the numerator and x minus 1 in the denominator because we have common factors here. So we can cancel this out, and then the limit of x plus 1 all over x plus 4 as x approaches 1. Now, let's try to evaluate this limit. Alright, if we produce a result like this, again, what we are going to do is to manipulate it again. We're going to transform it again. Alright, so, however, if we produced any of these results, then that would now be the limit. Okay, so the limit of x plus 1 over x plus 4, that is now equal to 1 plus 1 all over 1 plus 4. So this would now be equal to 2 over 5. Okay, so this would now be our answer. The limit of x squared minus 1 over x squared plus 3x minus 4 is now equal to 2 over 5. Alright? So, in manipulating algebraic functions or even trigonometric functions, you have to be very careful with the cancellations, right? Because there is a common errors that students tend to do when they're canceling out. Okay, so you do not cancel common terms, right? So you cancel common factors. So what I'm saying is that if you have limit of x plus 1 and then we have limit of x minus 1, say for example, you do not cancel out x here, right? Because this is because these are not common factors of both numerators and the denominator, right? So this is this is incorrect, right? So this is one common errors of students when it comes to manipulating or transforming algebraic functions, all right? So you do not cancel. So if I'm going to write it, you can write it on your walls, all right? So you do not cancel common terms. All right, so that is one of the common errors of students, or yes, students when they're trying to algebraically manipulate a functions. Now let's have the third problem here. So find the limit of x cubed plus x squared minus 8x minus 12 all over x squared x cubed minus 4x squared minus 3x plus 18 as x approaches 3. Right? So the first thing that we're going to do is to determine f of 3 in this function. Right? So this is now equal to 3 cubed plus 2 squared minus 8 times 2 minus 12 all over. Alright, so let me just correct this one. This should be, alright, okay. So that's 3 raised to 3 plus 3 squared minus 8 times 3 minus 12. Okay, and then for the denominator, we have 3 raised to 3 as well minus 4 times 3 squared minus 3 times 3 plus 18. Right? Now, you can always use your calculator to evaluate this one. So, if you're going to bring out your calculators there, we have 3 raised to 3 plus 3 squared minus 8 times 3 minus 12 all over 3 raised to 3 minus 4 3 squared minus 3 times 3 plus 18. Right? So it says here that this is indeterminate. All right. So we do not know. We do not know if um, we do not know, or in your calculator it might say that math error here. So what we are going to do is just we're going to evaluate the numerator and the denominator independently first, right? So evaluating it simultaneously does not work, so or did not work. So we're just going to evaluate it independently. So 3 raised to 3, 3 raised to 3 plus 3 squared minus 8 times 3 minus 12, right? So that's equal to 0. All over, so that is 3 raised to 3 minus 4 times 3 squared minus 3 times 3 plus 18. Alright, so that is also 0. So yes, this is an indeterminate, or the result here is indeterminate. Alright, so this is indeterminate. So since that is indeterminate, what we are going to do is that we're going to manipulate this one. Alright, is it factorable? Right. So what we are going to do here is we're going to manipulate this one in order for us to produce any of the desired limit result. So, or if there is no such limit in this function as x approaches 3, then the result would be L over 0. But if that is 0 over 0, then we need to manipulate it. So, to manipulate this one, let us check if that is factorable. And the easiest way to check this, if this one is factorable, is of course by using our calculator. So you can bring out your calculator and you can check the mode and go to polynomial degree of 3. Right? So since the degree is 3, then we can check if um, these are factorable, okay? So we're just going to input our coefficients here. So the coefficient of x cubed there is 1 on the numerator, right? So the coefficient of x squared is 1. The coefficient of x is negative 8, and the coefficient of or the constant is negative 12. So if we're going to press the equal sign, we have x equals negative 2. That means to say that one factor of this one is x plus 2. Alright, if x is equal to negative 2, then one root or one factor of this expression is x plus 2. Alright, so we're just going to write it. The limit of x plus 2 and then 3. Another root of this equation, or this expression I should say, is 3. That means to say that one factor of this expression is x minus 3. And if we're going to press equal sign again, alright. So if you're going to notice, when I pressed the equal sign for this equation or for this expression, it only gave us two roots, which is negative 2 and positive 3. That means to say that one of these roots, right? So one of these roots are repeated. Now, it can be that the repeated root is x plus 2, and the distinct one is the x minus 3, or the distinct one is x plus 2 and the repeated one is x minus 3. So one way to find out is to use synthetic division, right? So by using synthetic division, we're just going to write it here. The coefficients, we have 1, 1, negative 8, and then negative 12. And then we're just going to use one root here. So we're just going to use negative 2 in here. By using synthetic division, we bring down this one, so that's 1. And then we multiply this and this. 1 times negative 2, so that's negative 2. And then we add. Alright, so that's now equal to negative 1. Negative 1 times negative 2, so that's equal to positive 2. 8, negative 8 plus 2, so that's equal to negative 6. Negative 6, negative 1, so that's equal to, negative 6 times negative 2, so that's equal to positive 12, and then negative 12 plus 12, so that will give us 0. Now, the resulting expression would now be equal to x squared minus x minus 6. Right? And if we're going to factor out this one, the factor of this by trial and error or by inspection, that is now equal to x minus 3 and then x plus 2. Right? That means to say that the repeated roots in this expression is x plus 2. Right? So let me just write it here. X plus all over. Okay, all over, how about the denominator? What are now the factors of the denominator? Okay, so again, using your calculator, I'm just going to input the coefficients of x cubed, so that's 1. Coefficient of x squared is negative 4. The coefficient of x is negative 3, and then the constant is 18. Okay, so one root is negative 2, so one factor here would be x plus 2. Then another root is 3, so that is x minus 3. And then again, it only gave us 2 factors. And since the degree is equal to 3, one of the roots here are also repeated. So again, we're going to use synthetic division to do that. So, or to determine what root is repeated. So we have 1, negative 4, negative 3, 18. Right? So I'm getting the coefficients of the denominator. And then I'm going to use synthetic division, so let me just use negative 2 here. So negative 2. If I use negative 2 as my root here, and then I'm going to divide it using synthetic division, we now have 1, negative 2, negative 6. Alright, so negative 6 times negative 2, that's equal to positive 12. Negative 3 plus 12, that's equal to 9. And then 9 times negative 2, that's equal to negative 18. Alright, so there is the remainder is equal to 0. So that means that the resulting expression would now be x squared minus 6x plus 9. And this is actually the binomial expansion of x minus 3 raised to 2. Right? So the repeated root on this expression is x minus 3. Right? There we go. So as x approaches 3. Now, if we're going to simplify this one, we can cancel out x plus 2 in here. So it's going to cancel out x plus 2 and x plus 2 because we have a common factor here. We can also cancel out x minus 3. Thus, the resulting expression would now be, or the resulting function would now be x plus 2 all over x minus 3 as x approaches 3. Right? So if we're going to evaluate f of 3 in this function, we'll now be having 3 plus 2 all over 5 or 3 minus 3. Alright, so this is now equal to 5 over 0. And since 5 over 0, right, so let's check our notes here. If that is L over 0, the conclusion here, the limit does not exist. Alright, so therefore the answer here would be no limit.